6.5, example 2. Now that we've looked at how to break apart a fraction using fractional decomposition, the next step is to actually learn how to integrate them. But before we go ahead and integrate this function, we have to talk about the conditions for using fractional decomposition. In order to break down the fraction into smaller pieces, we have to have the denominator be larger than the numerator power. So if the denominator's power is smaller, then that means that it's going to need to be divided. Okay, so this goes back to your algebra skills, and we're going to have to do some long division here. So we're going to divide x squared minus 1 into 3x to the fourth, and don't forget, wherever you don't have a power, you need placeholders, plus 0x cubed, 0x squared, plus 0x plus 1. Right, because our function was 3x to the fourth plus 1. Okay, so in order to make a x squared 3x to the fourth, we need 3x squared. So we get 3x to the fourth minus 3x squared, and we subtract. So these cancel, and we get 3x squared plus 1. So this is going to be plus 3, 3x squared minus 3, and we subtract, so we get 4. Okay, so this is going to be our remainder here. Now, I'm going to show you how our new integral is going to look. So we have the integral of 3x to the fourth plus 1 over x squared minus 1 dx, and now that's going to equal the integral of 3x squared plus 3 plus 4 over x squared minus 1 dx. So this piece came from the long division, and the 4 in the numerator came from the remainder. Okay, so now we can use our integral properties to kind of break that up. So this becomes the integral of 3x squared plus 3 dx plus the integral of 4 over x squared minus 1 dx. So for this portion of it, this part is easy. It's just regular integration. But for this part, we're going to need partial fractions. So I'm going to go ahead and I'm going to work out the partial fraction part on the side over here. So this becomes 4 over x squared minus 1. So I'm going to factor it. So I get 4 over x minus 1, x plus 1, which is equal to a over x minus 1 plus b over x plus 1, right? Because you want to break it up into each piece. Okay, so we're going to multiply everything by the LCD. So on the left side, everything cancels, so I'm just left with 4 is equal to a x plus 1 plus b x minus 1. So I go ahead and I distribute. So now I'm going to set up my two equations. So notice on the left side, I don't have any x values, so it's 0. So 0 equals to a plus b. And then for my constants, 4 is equal to a minus b. So because it's pretty straightforward, you can just add these because one of them is going to cancel. So if I add these cancel, and I get 4 is equal to 2a. So a is equal to 2. Then I plug a in to get b. So 4 is equal to a minus b. 4 is 2 minus b, and then negative 2 is equal to b. So there's my a, there's my b. So I can go ahead and rewrite this now as partial fractions. So this would be the integral of 3x squared plus 3 plus the integral of 2 over x minus 1 plus negative 2 over x plus 1. Right, that's using the a and b and plugging them into these values here. Okay, so now the integrals become super easy with partial fractions. So this is just going to be x cubed plus 3x plus 2 ln x minus 1 minus 2 ln x plus 1 plus c. And that's kind of it. We need to do more simplifying, but that's the calculus step. So there's, right from here to here, that's the calculus step. All right, so now we just got to clean it up using our ln properties. So this is x cubed plus 3x plus ln. Don't forget to put this absolute value. It's really important. People often forget it, and then they end up getting things wrong. So one more step, and then we're all done. This is ln, and then using ln properties, we can make it 1 ln. And when you subtract, you divide the insides.